I know many familiar faces because I work in my job. And then also friends from different countries, from Thailand, from Taiwan, and so many. I'm very happy to meet all of you. I just have to follow you. Yes, okay, right. So once again, thank you, Professor, for a very nice introduction. Today, I'm going to talk about the history of Indonesian internet infrastructure development because last 2 weeks I had the opportunity to visit Internet Rakyat, which is search company, which is entity Docomo and Baicel. Actually, they were supported by Open RAN of Baicel of China. So I think it was very good opportunity for me. I forgot to put the photo, but later on. So I will update on what is Internet Rakyat is called, the name of the product, which is based on Open RAN. But actually, they are still not sure about Ray because they would like to have its open also fixed wireless access. But whatever that can make the cost lower, they will choose that, and that is why I'm here. Next slide, please. I'm going to talk about the evolution and landscape of Indonesian internet infrastructure and also the how we are moving from vertical integration to cloud native networking also, and the use of overrun as the radio access expression of cloud native design now and convergence toward autonomous 6G infrastructure in the future. So next slide. So previously, back in 1976, Indonesia is one of the first country in the world that implementing satellite network using it's called Palapa satellite at that time, and it was a good integration for the whole country. But then I'm going to tell you more about the development and the history of the internet infrastructure from the opening of the 1.4 gigahertz band for public access that is being used by Search now for the Open RAN. So they just win the bidding by the government to use the frequency of 1.4 gigahertz. Next slide, please. So this is the evolution of the global cellular network. In 1981, we used 1G. I think it was like this big when you use it, and it's analog voice, IMPS. And also in 1992, we started 2G, which is starting with SMS, GSM, text-based also. And also 2001, we start with the data era, which is using UMTS, Universal Method for this. And also in 2011, we start to use LTE. I still remember when we had the class here, we are talking about LTE and different deployment for those that is working on LTE. And 2020, we start using tactile internet, massive IoT everywhere, and we start with 2030, we'll have the 6G, which is projected massive rate latency and the rural coverage that will cover most deserted places. So from 2011 and 2030, all of us here are trying to work with the software-defined network to use software rather than hardware approach to make the architecture more cheaper than before. So previously, the core architectural shift, we see that 4G monolithic to 5G microservices. And then for 6G, we use function or serverless function as a service. And network are evolving from mere connectivity into virtualized intelligent digital infrastructure. So then you use RAN, DU, RU, and those things that previously some I think work with G0B implementation and so many things that we've been witnessing that the Open RAN community is trying to do just the same thing. Like this is a proprietary, for example, Apple, but then we have the open one with Google, and then we have Android, so that's open for everyone connected. Next slide. So if we see the Indonesian history, 1976, we have Palapa A1 satellite. and become one of the first developing nations to operate domestic satellite system at that time, binding the archipelago into a single communication system. And in 1994, I remember it's the first national internet exchange, commercial internet being provided in Indonesia. And at that time, I remember that I do some master course on economics, and I interview the human resources also at that time. And it's really interesting how this community and how this startup also have been trying to provide open access, open public access to internet more easier. In 1999, we have the Telecommunication Law number 36, year 1999, which is the regulation that set the spectrum usage in Indonesia. And then 2019, we have Palaparing completed. It's not just through the satellite network, but also we need an infrastructure for fiber optics, so it's quick. We put some submarine cables, some terabit class terrestrial fiber routes, which normally we require that to connect the eastern part of Indonesia, especially because it's very costly. Because the user is not that much as not that many as the one in Java or in Sumatra. So in 2023, we have Satria-1 in orbit. It's a geo satellite for public services. 2025, just last year, October, we announced the regulation in which they opened the band, and the winners of the 13th is in the 13th October e-auction were sent into the company. It's called Search, and that is the company that I saw yesterday. And they actually checked. They have ZTE, Huawei, Nokia, Bicel, all these big also try to put their network together. So it's the coverage that is really important to lower the cost for the society to use that. And 2026, they announced the world first commercial 5G fixed wireless access network on 1.4 gigahertz over Open RAN running in Indonesia. Next slide. So, well, this is the Indonesian digital ecosystem. We have 22 billion people and 350 million mobile subscribers. We have fiber optic backbones, submarine and terrestrial routes, according to most likely is connected to Singapore and to Australia. So we have many internet exchange that keeps the domestic traffic local and lowering latency and transit costs. And we have the layered national stack here, access layer, aggregation layer, and core layer, in which we have a mobile network, fixed broadband, fixed wireless access, and satellite links that reach the household and public facilities. This year, President Prabowo announcing two important projects, which is a cooperation co-op that he installed in all the villages in Indonesia. So this is going to be also connected, plus many programs to combat stunting and things that require a lot of information that is going to be processed. And that is why we also think that lowering the cost is something that we need to do, and using open RAN and open source approach is the most effective way to not to be following all the proprietary systems. And also the core and compute layer, national backbone, national data center. We had problem also with that. So it's going to be more towards private sector rather than previously we tried the national data center with based on the availability, but the continuation of funding and everything is required. So many startup and also commercial approach for that. So also hyperscale co-location system and virtualization of network function and many things. Next slide. So we have persistent digital access defined at the moment. 66% individual internet penetration, 21.31% households served by fixed broadband. So only these that have the uh, um, or what you call it, the fixed broadband network, fiber network directly to home. And also this is the speed, 47.10 Mbps, and the public facilities lacking adequate access. So we have to really connect it that because more and more like the government send all these big new facilities to schools everywhere, but the one important thing is they need connection, access to the network. Next slide, please. So that is why end-to-end deployment architecture is really necessary. In stage one, we have the backbone, national fiber optic, built on Falapari, submarine cables, and also stage two is backhaul from point of presence to local base station through regional fiber, microwave radio, and satellite gateway, and also then the connection to the last mile, in which we need fixed wireless access to achieve the customer, using the antenna distributed via local Wi-Fi. So supporting pillars of this access layer is fixed wireless access, which is having point-to-point, multi-point links, go straight to customer premises with no entrenching. So then also we have a hybrid GEO and LEO satellite to cover as a fast backhaul complement to the remote area, complementing that, and also customer premises equipment using open wireless router based with modem with 3.5 dBi on the antenna and Wi-Fi network. Next slide. So, having to know this, the latest development is that we've been working a lot during summer like this, and see your presentation. All of you have seen this, maybe from simulation, like I've been teaching of NS3 for a long time, and now so many deployment of AI to be putting together. But we've been using um, simulation for this approach. So, and vertical integration to cloud native networking is something that we do. We have software defined control, virtualized function, and computations is pushed towards the edge, not only the server side. Next slide. Okay, then during that time, all of us learned that we have to move previously. I was the first time I learned about Kubernetes and about these containers was here, with all the students, and it was like already being implemented in the current Open Run system. I remember Nafit also works with orchestration, well, like 7 years ago, and now is there, yeah, in which we have the 5G core with edge server, and we have monitoring system, 5G core, Cloud Run, Kubernetes, Linux. We have containers, observability, and also edge cloud, in which modern telecom engineers must understand both radio approach and also cloud native infrastructure. And eventually, now, I talked with Professor Cho. He was also working with discussing about AI run and AI ops and network API automation. So many things that we are required to learn, but I'm sure that you will be able to learn that when you are doing that by in practice. I recall 2007 when our president went to Huawei. He brought up Huawei EVDO 2001, and it was put into my university. I was the one who hosted that, and actually as a training center, it could not be used a lot, because what is good is that you follow the engineers, you see what they're doing, and then you implementing it directly. Like that is what being conducted at the moment. Yeah. At the moment they push you all. Just go and do it. You know, you will learn and you can do it, and you can work and extend the network for that. So also we will be pushed towards ensuring that this new toolkit like Kubernetes, Docker, Prometheus, Grafana, Elk. I remember all the students sometimes that is working on this, uh, and now the approach is quite different, but we know that we have to move and to put together by implementing that. Also, the integration and the monitoring system and performance evaluation is number one thing that you are required um, to master. So radio frequency, AI, automation, and application programming interface is something that we need to look into. And I'm very happy to meet all of you, very fresh faces that is going to see how it is being to change the whole community. Well, in last trip to the search, I met two previous year participant or intern and take some pictures with them. I'm very happy that they already they are doing very well. I met them in the monitoring system area, network center monitoring. Okay, so next slide, please. We see the architectural shift underway. We have software-defined networking, then network function virtualization, and edge, fog, and mist computing being conducted. We also learn about network slicing and intent-based communication, intent-based computing, and also, for example, for one slice for IoT, another for vehicular traffic, another for voice. Intent-based networking lets operators declare the desired outcome and leave the configuration to the system. So we can see that there are so many things coming up and moving towards edge computing. Next slide. Okay, so we also see previously software as a service, function as a service, platform as a service, container as a service, and base layer is infrastructure as a service. Also, the operational foundation is that we have containers orchestration, Kubernetes and Docker schedule, and heal the workloads that carry network functions, replacing the fixed application appliance with elastic pod and other things. And also open source ecosystem, and automation and self-orchestration, in which we see that previously back in 2000, I was working with active network. And at that time, we were talking about self-healing, self-everything network. It is happening now because with the AI, everything is being cleared. And well, soon it's going to be post-quantum network and computation is going to be quicker, and we have to find solution also for that. Next. Okay, right. I will see how later on maybe Prof. Ray can add me more on this about the Open RAN, and maybe if you could see back what we have been doing, Prof, because we have contributing towards all the testing of the Open RAN community, and also do some AI and RAG implementation and things. We will see how engineers can learn and also can change the world together in an open source community like us. Next slide. So Open RAN is decouples RAN hardware and software through open standardized interface, letting operators deploy components from many vendors on cloud native infrastructure. So yeah, as you see that all these vendors that I told you, the 6 vendors are working together in research, the company that I'm talking. They are trying to have more than 5 million connection this year, but we never know how far they can because they have laid the fiber optics on the railway track. all over Java. So we will see how, because so many people already registered, but they are working very hard night and day to implement that. And also they have the RIG, Run Intelligent Controller, which run apps for real-time control, while the non-RT RIG inside this runs apps for long-term policy. So we'll see that the optimization of the network is using AI and machine learning approach. Next slide. Okay, what is the difference between the RAN and Open RAN? You can see here. Maybe later Prof. Ray can tell us more about what we have seen, but I don't see that they were mentioning the SMC, but they don't really implement a lot of. Maybe you can see also the implementation of Taiwan to Open RAN, because they don't. When I went there, they said that the MSC was not really keen on whatever. Yeah, but maybe you can tell us more about this between the traditional RAN and the Open RAN. Next slide. Also about the governance of the spectrum. So the government govern the public spaces, which is the air, the frequency being owned. So the communication and department, the ministry in Indonesia do that. They do e-auction, and one of the speaker was the director of that last week, and we were talking about the obligation of the operators when they are running the satellite services, mobile satellite service, and all the access to passive infrastructure. I remember Prof. Cheng 2007 when we tried to make the EVDO 2001, we were thinking about providing the service to University of Indonesia only. Okay. We asked the government, can we have this frequency, and they say no. So yeah, but I'm sure that that time is not that mature yet, but now it's going to be something like being conducted and being used. So this is the coverage of the different company for search and different company that is having that. Next slide. So for the broadband wireless access, we are all in this laboratory here. BMW, no. Yours is broadband mobile. Yeah, access. Yeah. This is broadband wireless access, in which we need a fixed network-based telecommunication service for internet access using the radio frequency spectrum. And well, at the moment, we require a big bandwidth. Previously, in big city, they have the fiber optic, but to make it cheaper using this, we require to have the fixed wireless access. Next slide. Okay, this is the radio frequency spectrum landscape in Indonesia. We have the existing IMT band being used, short-term release of this, and also the IP band expansion. And Indonesia applies a technology neutral policy across all this IMT band. So currently they are trying to sort it out, but we hope that it will create an allocation in which people can use that, because at the same time you can also think that people think about the use of satellite, for all the communication. Okay, so next slide about the value of Open RAN. It's opening the competition and innovation. Capital expenditure is being shared, also operational expenditure efficiency will be gained. This is what we were talking about, about the economic side of that. We have a growing national industry of only local vendors, startup, because we have local content that should be provided by the operator and vendor. And also network quality and security, in which dynamic optimization through virtualization, automation, and AI machine learning keeps the network reliable. And creating a foundation for the future networks, in which we support 5G advanced and 6G edge computing and next generation digital services. So this is the measurable impact that they're saying. 30% of total cost of ownership, 23% of global virtualized RAN and open RAN projects already in commercial production, and at least 40% of tier one operators will deploy by 2027. So they are working hard on this, and also other problem of capital expenditure. Next slide. Okay, technical challenges, security and policy agenda. We have technical challenges like shared medium brain attenuation, multi-funder integration is required, and also data and network security. We have personal data protection law compliance, CPA vulnerabilities, and wireless interception. So this is something that we need to really cover, and a joint policy agenda for operators, the Ministry of Communication and the technical community, in which we have to make sure that hardware and software supply chain security is being provided. Universal obligation scheme to speed up the remote area access to the internet penetration, and also cross-vendor interoperability and faster time approval for 1.4 gigahertz open RAN equipment. Next slide, please. So we can see also many global best practices in access in this. In access equity, in which we see in Indonesia, in United States, and in India. We learn a lot about that. The use of fiber optic and different mechanism to make it the cost efficient. And also the common thread is that all three target at least 100 Mbps, and the differentiators are pricing instrument and openness of passive infrastructure. So open and integration capacity is very important. Next slide. So what about the future of autonomous 6G infrastructure? Where AI stop being a feature of the network and start being its operating principle. So when we need to use AI, we in the 6G infrastructure, we are required to make sure that in the future it's helping us to overcome all the problem in the network. Next slide. Okay, so we've been talking a lot about agentic AI. Last year, many of you doing many things with agentic AI, and also AI RAN, radio access design, so that interference and radio processing share the same accelerated compute, and the open RAN architecture, where apps and RFs in the RIC become the entry point for learn control. And also, we learned about the intent-based networking. This is the BMO is working on this, right?
Now, just, also.
Intent-based networking. This is very important things, and also digital twins, virtual replica of the physical network, used to test the configuration, a slice, or a failure scenario before it touches production traffic. So we're hoping for a self-healing network that can overcome the problem. So next slide, please. In improving this year alone, if we see the hype cycle of Gartner, now agentic AI is right at the peak of inflated implementation. So everyone is trying to solve their problem with agentic AI, including this telecommunication industry also. So if we see that here, in the peak here, in inflated expectation, we will see that is being embraced and being used in the community. We don't hear it anymore, and suddenly it's just in the slope of enlightenment and plateau of productivity. So that is what the cycle that we see in the technology that we learn. Now you are going to tell us more about what you are doing, and Prof. Ray already selected some topics that is very, very important for our involvement in the development of telecommunication and IT digital infrastructure. So why, next slide. What 6G actually demands is that we have massive data rate, massive low latency, massive reliability, everything that we've been calculating and try to solve during the performance evaluation of the network. Massive scalability in order of 1 million connection per square kilometers, massive security, resilience against jamming and interception, design in not editing later, and also massive rural coverage. This is very important for a country like Indonesia. We covered like from New York to Los Angeles. That is how big Indonesia is. And rural coverage is very, very important. Reach as an explicit design target, which is precisely the Indonesian problem at the moment. And also the constraint that is easy to forget is that sometimes we know that when we're talking about this, we really need to have the basic access, which is electricity. Yeah, when our Minister of Education buy a lot of Google Chrome, Google Book, then the problem is some of them don't have electricity and access to the network. So we have to think about that. In rural area, this is the problem. And it's very expensive also. So any 6G architecture that ignores energy will fail on cost before it fails on physics, because yes, we need to make sure that the basic infrastructure is there, the hardware acceleration, and also ensuring that it will be flexible also during the deployment. Next slide. So what is the competencies required for the next generation infrastructure engineer? First, we need cloud native architecture engineer, Kubernetes and containers engineers, which creates orchestration, service meshes, and the operator pattern. Well, we have to do the virtualization time and core function and many things, and not network automation, AI agent and applied machine learning in order to make sure that the X apps and the R apps is working and knowing when a learned policy should be allowed to act on a live traffic. We are always using the approach of simulation because we don't want the real network to be cluttered because of the experiment that we are doing with the machine learning and or AI training, for example. Security by design, zero trust mechanism between these aggregated components and compliance with personal data protection duties, and also sustainability and energy. We need to make sure that the usage of energy is being counted. Remember that everything we do, we always use energy, and a lot of things may be wasted because we are doing some experiment, but AI requires a lot and big energy. So we have to think about that, this implementation and how much throughput and latency of the system, and also how the cost of the use of energy. So we hope that all of you also going to be considering green jobs in which when you do something, you also think about the usage of energy. Next slide. Well, it can be concluded that from 76 to now, it's already 50 years, half century. We were very proud at that time because so many countries, including Singapore, also borrow our satellite at that time. Yeah. So we have organized to be organized in the future, making sure that this is going to be the transformer of the economic power for the society. In Indonesia now, if you buy things, you don't pay with Bitcoins anymore because their QR code has been used everywhere. So to sell things. Yeah, I think that is the difference, big difference, because I just went to the whole Europe just on Saturday, through the 5 countries on the middle side. All of them are using different coins, and it's quite difficult for the integration, but we already use that.
even Malaysia also moving toward the QR based payment. So our Internet Rakyat is the case study in which we will see whether the aggregated model can be deployed at scale to lower the cost and to improve the coverage against all the remote areas in Indonesia. And it's very, we required a lot of hard work to implement that, to collaborate and make sure that our system can be open and can integrate with other vendors approach. So we need engineers that is fluent in cloud native system, orchestration, automation, and all of you are being trained to do this now. Yeah, applied AI and security, which will place the burden. It's not only when you are doing it, you know that you can learn it by yourself, but when you are together with your friend here, and also tomorrow, for example, we'll see how the implementation in the industry in which the funding and the investment is already there to support you, your research work later on to be implemented in their products is going to be something that will make you satisfied. So yeah, I'm very happy to talk in front of you, and you are going to share more on your work. But I would like to invite Prof. Cheng to reflect back about our involvement in this, because when we see these big industrialists, they know how to make the money, but we are preparing all of you to be those that is going to change the world, going to provide new services, new way of working, new way of living, and new way of doing things that no one in the past already think about it. So once again, I congratulate all of you for being in this community, and please, Prof. Ray, please also share your opinion and your history. Thank you.
Thank you. Thank you. Let's thank Professor Riri for the great talk and good sharing. Actually, we are also learning to how to work with the open source community, learn from the open RAN society. I guess Taiwan. I don't know whether the company you mentioned says that they don't have Taiwanese company, but I guess you can consider to invite some partner from Taiwan, because we have many good vendor. Actually, they are manufactured from Nokia, Huawei. Not Huawei, but Nokia. I guess Nokia Ericsson in the past. Yeah, so it should be the good opportunity to co-work together. Yeah, they already have a product, and it's good to allow them to promote their product, because now for fixed wireless, I guess there are already some company in Taiwan. They already have open RAN product, but it's not. I guess it's not as good as Nokia and the Ericsson to support high mobility. But for fixed wireless, I guess they already have some small cell product. They also have outdoor antenna radio unit, or they can work with commercial RU. So this could be one of the potential way to tighten the cooperation between the two countries, especially you can get some many different product, open RAN product from Taiwan. Yeah. So that's what I know. Yeah. We also have many different kind of company. The TSMC you mentioned, actually is many company finally they need to have a chipset. They need to go through TSMC. And actually many company originally they develop a radio unit in terms of FPGA, but we also have company they try to use ASIC to replace everything, so they can quickly drop down the cost of a radio unit. For example, a few years ago, we started to do the end-to-end testing with commercial RU. Is one may cost maybe $5,000 per unit, but now it can reach maybe 1,200, only 1/4 of the price for a single RU. But if you purchase lots of the unit, it could be much better. And actually, Taiwan also have many server. We also have many, even Wi-Fi. They are. We also have many good one. For example, everybody knows Aruba from United States, but few people knows the Wi-Fi AP for Aruba. Actually, the Wi-Fi AP is manufactured by WNC. WNC, you have some classmates now. They take intern in WNC now. We are good at make big volume, low cost, reliable hardware. But this company, they also try to build up some new software on top of it to increase the value of their product. So I think that's a good opportunity for everybody. Yeah. So since Professor Rui is busy now, so I guess we can take a 10 minutes break. So since it's 2:50, we can come back on 3. Then maybe we'll share the section for the rest of the part.
Yes.
You need to impress Professor Rui such that your junior may have the chance to continue to come here to Taiwan. So it's all your obligation. Okay, let's take a 10 minutes break. Thank you.
Hello, Ray. May I say hello to Professor Riri?
Kalau mau matiin di keyboard aja atau bisa? Ini mau nunjukin video kalau DTE. Ada di line kemarin dikirim Prof. Oh, tadi sempet aku edit. Imagine. I don't know, audionya bisa tapi it's fine.
Ini kemarin lebih. Kalau yang kedua apa?
Aku nggak tahu, cuman itu sih testimoni konfliknya nggak ada lain. Saya mau mainin aja. Testimoni. Ini pura-pura. Test. Oke. Kayaknya nggak parah tapi it's fine.
Okay, thank you, David. I will start my session now. Good afternoon, everyone. My name is Laura Fauzisambo. You can call me Laura. And here I am, the BMW Lab intern, specifically for promotional and operational tasks. And before I start introducing what TEEP is, I will start with a collaboration video that I did for Department of Electrical Engineering, University of Indonesia, and BMW Lab and TSD.
I don't know if the Oh, there's another one. I think it's okay. I just want to show the video.
This is one.
It's already off. Okay.
No.
No worries. Nyambungannya gimana? Ya, aku nggak tahu. It's okay, bro.
It's okay.
Okay, since the audio isn't working, so I'm just gonna explain a little bit about the video. So, this video was made for the 8 years of collaboration between Department of Electrical Engineering, University of Indonesia, and BMW Lab since 2018. So since the first batch of TEP students, there's always been Indonesian students among them, and up until now, we're still collaborating till 2026. This is some testimonials from the current students. I'm just gonna skip. There's David and also Kiara. And then these are just some pictures of the alumni from 2018 to 2025. This collaboration, Okay, so that was the collaboration video, and now I'll be starting my presentation. Okay, so good afternoon, everybody. My name is Laura, and today I will be telling you a little bit more about the TEP program, which is the Taiwan Experience Education Program. So since okay, 1 second. Okay. So as I've said, my purpose here today is to explain to you a little bit about what the TEP program is and what I'm doing here. So the TEP program stands for the Taiwan Experience Education Program, and for BMW Lab, there's many programs here, but specifically for the BMW Lab, it's over here. Yeah, so there's many collaboration of the Taiwan government that has been supplying the students from international students to go study and do internships in Taiwan. And one of them is us here from Indonesia, from University of Indonesia, from Teknoperan Nusantara, and also ITB. And for OE itself, we've been collaborating since 2018 until now, 2026. And this is what I'm doing here. So I'm focusing on the BMW TEP student experience and outreach system. So I'm here to do the system standardization and end-to-end lifecycle and also sustainability and scalability of the program. And what matters is, of course, we want to keep this program alive. So we need to boost the operational efficiency, enhance the program visibility, and also preserve the institutional knowledge that has been here for the past 8 years. This is my 8-week roadmap. We're currently on the 3rd week. I'm focusing on the student insights. I made a Google form to see what the students and also alumni have experienced and also analyze the data from there. And again, I'm focusing on outreach and also operations. This is my current progress. So for the 1st and 2nd week, I've completed some videos, established some systems, and did some engagement on the social media. And for this week, we're focusing on industry. We'll be doing a company visit tomorrow to Groundhog. I'll be doing SOP checklist and also analysis. And if you haven't followed yet, these are the social media for BMW Lab. I'm currently focusing on Instagram. And that is all for me. Thank you. Next up is, I'll give the mic back to David.
Okay, thank you, Laura, for the introduction. And from now on, we will cycle through the lab interns to show what each of us are doing right now. So maybe I will start from myself here. And this is the same overall presentation that I used, I think, 2 weeks ago or last week. And to quickly recap, my name is David. I'm also from University of Indonesia. And my major is computer engineering. So the basics I'm covering here is the orange split, right? So right here we have the 5G core, which controls the network services. Then we have the OCU, or the central unit, which is the higher layers, the ODU, which is the lower layers, also known as the distributed units, the ORU, or the radio unit, which controls the RF functions, and finally the UE, or the user equipment, like phones and etc. So orange here separates the base station into open components and makes the system easier to test. The ORU itself, which I'm focusing here, as my topic is about optimizing ORU power usage to more similarly imitate WinLab's results. The ORU itself is the open radio unit, and it is important because it can consume very significant power when left undocumented or unsupervised, and it handles the radio and RF side near the antenna. In my work, the physical target is the Pegatron ORU, which we have in the BMW lab. This is the radio facing part of the ORAN. And this is, to quickly recap, the WinLab inspiration that I'm basing it off on. This is the curve that WinLab has. And they use POET as the method to study and measure power consumption in ORAN testbeds. The current lab test flow is that I'm working on the HPE server, which has the core network setup, the OIA GNOB, the Pegatron ORU as the primary target for our testing, and also a remote PC, which acts as the UE, and we access this via AnyDesk. And to test the net flow itself, we use iPerf to generate traffic. And in here, we use Cortex DC and InfluxDB to monitor the results. And this is the FOSIC and Cortex DC part, as I have briefly come over. The Cortex DC is like a dashboard that we can use to manage the entire lab's infrastructure and also monitor its performance, like its power via Redfish and also the temperature. And this ties into FOSIC, which has a topic on predicting the ORU's temperature. The goal from my side is to connect the network experiment timeline with the power readings. So this is how to measure the ORU power, like from starting the NF API deployment, attaching the UE, running iPerf, recording, exporting the power data, and then comparing the load. This is my current API plan. This is the system flow that I'm using. And from my current work, I'm preparing the baseline run label. This week I have validated the E2E test direction with SVE, UE, and Hyperflow. Right now I have made an RF to test the end-to-end flow more easily and more readily using bare metal and also using a Dockerized version. And the cloud run here is the GNOB plus UE iPerf. The artifacts will be logs and CSV plots, and then we can power mesh it. And for the next in line of my work is that I will test the Docker again and start aligning the E2E sweep test with the baseline power that we have that we can take from Cortex DC and also InfoxDB. I think that is it from me for my brief introduction. Thank you very much. Okay, and for the next
Question.
yeah.
Can you show us a little bit about the new tools that you're using, like Cortex and what do you learn and what is the most important new things, the latest one that you find is useful so that others can use for
Okay.
performance evaluation?
So the main tool that I'm currently using is InfluxDB and also Cortex DC.
Anybody uses Cortex or there's different already with first one?
For the other interns, I don't think my topic overlaps with anyone else on this subject, but I did learn this from the masters that currently are working on the lab infrastructure, such as Mr. Rafi and Miss China. So right now the wire guard tunnel is
Sorry?
to access the InfluxDB and the Cortex DC tools, we need to activate a tunnel. And I think right now in Windows, I cannot access them. I need to switch to Linux too. But it looks like similar to Supabase or NeonDB, but it can show us the infrastructure, the topology of the servers, and for each server, each PDU, it can show us how much power it's consuming, how much temperature is generating in a plot form. So it's like a data exploration tool for me mostly, since I'm mostly just reading the data.
So you're going to do contribution to the open run.
So my target is that I will use these power readings in order to analyze the pattern in which the temperature spike or drop and the power spike or drop. And after knowing that, I can then start modifying the server's power scheduling algorithms, which we use POAI for now. So my target is to modify this POAI scheduling algorithm in order to produce a more efficient power usage for RU.
So you will do the documentation also.
Yes.
Thank you.
Okay, thank you, Prof. I think next up, I believe in the schedule is okay. Yeah, I think next up in schedule is Fatam. Zoom-nya di mana?
This is the mic for the Zoom. The mic for the Zoom.
Oh, okay.
Okay, I will hand over the mic to.
Okay, thank you, David. Okay. Okay, good afternoon, everyone. Thank you, David, for the handover. My name is Fatan Yesusapri, and I am also a student from Universitas Indonesia, third year as well, same as David. And my research topic for TIP in the BMW lab is the approach message one attacker reproduction and mitigation. Okay, so let's just get into it to the second slide. This is a little bit introduction about me. This is the same PowerPoint I used for last week as well. So my name is Fata. I'm computer engineering third year in the sixth semester, coming into the seventh semester until when I get back from UI. And yeah, this is my role as a TIP research intern. This is my past experience, including the TIP online probation earlier this year, where my topic was about ORAN integration and analysis, which is a little bit different with my current topic, but still a little relatable. And also some of my other experiences, including another internship I did and some organization in UI as well. Okay, next up is my past projects, which if anyone is interested, they can just view them in my portfolio website. Okay, so yeah, let's just get into the introduction of my topic. So this is the PRASH introduction. PRASH is short for Physical Random Access Channel, which is the first layer of 5G network connections. So this is basically the the diagram of 5G network connection. So first of all, the UE device, UE is user equipment, which could be a phone, a modem, or any other device, sends the patch preamble to the GNOB and RU for radio access processing, which then the GNOB sends it to the 5G core, which can be used for data network applications. So here is basically the timing, and also for my own topic, I will use the SDR capable UE and a host control RF front end for the hardware, and also for the software, it uses a modified UE stack that synchronizes to the cell and reach the patch configuration and generates the message one patch. For the target hardware, it will be GNOB. It could there will be multiple targets I will use. So there's gonna be the lab GNOB, and then maybe a commercial USB GNOB, and maybe later if I have time, I will also try to integrate it with DGX or NVIDIA Aerial RAM as well. Okay, so maybe we go to the next slide. Okay, here is a more detailed diagram for the branch random access procedure. So as I said before, branch is basically the first connection between the UE and the GNOB, and it's here in the message one, the branch preamble, which since it's the first connection, it has no authentication yet. So the security is very critical because the detection happens before authentication, which is different than the message 2, message 3, and message 4, and so forth. Okay, from the diagram before, we know that the branch is there is a vulnerability in pre-authentication, and there's also a vulnerability because there's shared capacity because the GNOB uses access occasions, preambles, and the raw capacity are finite, and also the UE we use to attack can be cheaply repetized. So you can just modify the UE to ignore the answer, which is the message 2 from the GNOB, and just basically spam the message 1 like a denial of service attack. Okay, so here is basically my mentor's current mitigation of the patch attack. Basically, what his algorithm does, it detects the
and my mentors, Mira and Will, to bring this analytical and simulation work to life. This is the agenda. And this is my research goal. So this project optimizes next generation Wi-Fi 7 and 8 networks by translating dynamic URA and BSRQ analytical models and validated via industry simulations into a deployable RF for the SMO framework to enable real-time resource orchestration. So, and why this topic? So I always been driven by the goal of making networks smarter and not just faster, but I'm passionate about bridging the gap maybe between theoretical models and real-world deployment. And next is my scope and contribution. So where do I fit in? You can think of my role as building the brain, maybe the brain of the system. And if you look at the system architecture on the left, my primary responsibility sits right here in the theoretical modeling and simulation environments. So I handle the mathematical derivation. And the goal is to build a modular algorithm that can eventually be handed over the Orange SMO framework and via one interface. So to make that happen, the algorithm flowchart on the right shows the exact optimization logic and I am designing. So it's a closed loop process. For every slot, the algorithm monitors the traffic load, will calculate the optimal RARU allocation and bank of parameters. So and validates it against the Wi-Fi 7 or 8 constraints. And finally, it outputs an XML configuration, which is exactly what the Orange agent needs to automate the network. So, okay. So my current progress, I successfully reproduced the analytical model for Claire's paper and General's paper, and my industry environment on WSL2 is stable, and maybe I can try the industry simulation later. And I'm currently deep diving into Will's repo and fixing some VPN access. And next is everything is well documented on my GitHub, and this is the figure 4 from Claire's paper. As you can see, the nautical trend matches the paper perfectly, so which confirms that my transition modeling logic is solid. This is the foundation I will use to next step and validating it against the industry simulations. Okay, next steps and timeline maybe for the next few weeks. My priority is gonna be extending the industry simulator and to handle dynamic allocation. Then I'll move into General's formula refinement and Wi-Fi 7.11, 7.8 standard integration. And by the end of August, the goal is to have the dynamic algorithm fully designed, validated, and ready for technical handover to the team. That's all for my update. Please let me know if you have any questions or feedback. Thank you.
Very interesting, Kiara. So you've been learning from Genroms. What is Genroms' current implementation, and what have you planned to add up mathematically? You said that
So
you're going to.
Genroms is the paper that talks about URA before that works with Professor Ray. And right now I still to duplicate the figures on that first. Then I will try to derivation their analytical models and math. Maybe like that.
Okay, that's really good. So you run the NS3 already?
Not yet. I still setting up.
So what you this one is, how do you do this?
Oh, it's basically from the paper. I will try to match the graph from that paper to my personal notebooks.
how do you produce this?
With Python.
Okay.
Yeah.
You follow the algorithm in the paper and then create
Yeah.
the Python for that.
Yeah. So there's many figures on that paper that I will try to.
Is there any particular thing in Wi-Fi 7 or the 8 that you look into particular for your own development, or
Not yet.
you haven't seen the difference?
No.
But that's really good. Yeah, you follow 2 weeks only. Previously, you learned during.
I still learned a bit.
Right. Yeah. Very good, because I'm very happy to know that people are still using NS3, because for this, no other way than doing the simulation. So, very good. Please give applause for Mike. Yeah. I see. Yeah. All right. I see. Simply. Yeah. Very great. Yeah. Brave lady.
Oh, thank you. Yeah.
Please say hello. Christian.
Hey everyone, and good afternoon, Prof. Ray and Prof. Ray and Christian. So in CEP, I work with Johnson. Johnson is master student of Prof. Ray and also my mentor for this program. And I've been recreating his work, that is a synthetic data training for LLM-based 5G configuration management. And I will just briefly summarize what have Johnson's done. So the main contributions of Johnson's work is we're creating an open source framework to regenerate the synthetic data to fine-tune a model. So this is a whole pipeline for synthetic data generations. We didn't take care of the actual training. The actual training is handled by NVIDIA. So Johnson's are collaborating with NVIDIA, and we are only providing NVIDIA with the synthetic data for training. And this is a background of 5G end-to-end call flow, and this will be important for my next contributions. We can look this into 4 separate parts. There's this self-source component, random access component, the initial access procedure component, and the PDU session components. There are a total of 4 components in the entire 5G call flow. And this is the system architecture. This is what Johnson already built. The user will be a operator using synthetic data to generate tests if there's a misconfigurations in a 5G components. Yeah, so stakeholders will be an operator, management platforms, and the open RAN. But right now we are using an M. Yeah, this is the proposed method. First, we will have a workable configurations, the correct configuration, and we will mutate those configurations with LLM for the training data. After we mutate the configuration file, we will have another LLM to try to generate the correct answer, and we will collect the reasoning trace of that models, so we can fine-tune another smaller models. And this is what Johnson already have. This is the performance and the accuracy. You can see the base model is Quan with 32 billion parameters, only got like 20% accuracy, but after fine-tuning, we can increase up to 89%. And this is also the functioning with track. We can also increase the accuracy even more with track. Yeah, so that's a little bit of what Johnson's already done, and now is what my contribution to Johnson's project is. There are total three contributions. The first one is I will create a benchmark for Johnson's model, and not only for Johnson's model, but for all upcoming models, for anyone who wants to build a open source model, they can use this benchmark for each 5G call flow. So I mentioned earlier there are a total of 4 main components. I will generate each test data for cell search, random access procedure, and PGU sessions, and of course the benchmark results, not only for Johnson's model, but for other open models also. And I will also test this whole project, does it really work in the real life configuration problem? Because right now we are only having a synthetic data generated. So we want to try with the real Open RAN, where we can get it from the email refactor or by the GitLab issues. And also we can test the model with newer open source model, because Johnson is using Quan with only 32 billion. So it's kind of old and it's a small model. We can test with newer and bigger models. And this is the current progress. I have created the cell search parameters and benchmark. There is a total of 50 test cases. And I have tested it to 4 different open models like Nemotron, GPT, and Gemini, or Gamma 4. And Gamma 4 surprisingly works surprisingly well, even though it's only 32 billion and 31 billion parameters. I don't know if this is it about my past data or it's just Gamma 4 is really good. I'm not sure, but the difference from GPT OSS to Gamma 4 is kind of a big jump. It's almost double. Yeah, even compared to Nemotron Ultra. You use API or? Oh, we're using an API. This is using NIM NVIDIA API. All of this is using the API. Yeah, this is a quite surprising result for Gemma 4. Yeah, I think this is my current progress. So then for the next weeks, I will create all these new parameters for random access for the other components. And this is what I have faced currently, just yesterday maybe. So I have tested Johnson models. I have deployed into our local computer, our local environment in this lab, because previously this model is being run by NVIDIA. I want to try to run it in our lab, but I face an issue that this model is having a model context size limitations. That's why in this result, I didn't pass Johnson's model, because we are facing this problem. And the solutions will, I only think of summarizing the input, and I don't know about other solutions, other possibilities. Maybe it will come up with newer discussions with Johnson and NVIDIA. I think that's all that I can share for today. I'm hoping to discuss a lot more with you guys and with Prof. and with Johnson for the next 2 months.
Okay, Christian, you've tried many. Where is the contribution of using NVIDIA here? Is it Nemotron or what is NVIDIA using for?
Yeah, so actually Johnson's collaborate with NVIDIA to do the fine tuning. So we only give NVIDIA the testing, the training data, and NVIDIA will do the fine tune and they will give back the models to us. That's first.
Access to their facility or?
No, we only give the data. They will do all the hyperparameters tuning and all of that. It will be given to NVIDIA.
They do it directly or?
Yeah, they will do it. They'll do it on their site, on their server and the computer. We only get the models back. But for this one is different. This is outside of NVIDIA. I just want to try to use the Nemotron models.
Different one. I see. About this NVIDIA thing, do you know what kind of machine or or anything that they're using particularly for that now? And do they do it directly after you request it, or?
Yeah, I'm not sure about that because there's, I think Johnson.
Okay, I can clarify for this part. We work with, can you go back to the video? The purpose here is we want to train a LLM model for debugging, for configuration debugging. Means that we use the lower part is the management platform. This is actually the SMO and rig. We will use SMO and rig to configure OAI base station. So after configuration, so we can automate all the configurations. So the configuration file will be generated by the operator. So operator in the future, the operator only need to give us the intent. Then intent will be translated by LLM model. So LLM model will use management platform to configure the base station. So after configure the base station, we can do the test automation to make sure whether the handset can connect to the base station correctly or not. In case in the initialization of base station some problem, now we focus on the configuration of the base station. So the configuration of base station, if they have anything wrong, we will get a log from the management platform. So in this case, we can collect the data, configuration file and the log. So this is the synthetic data generator, what we are doing now. We use the configuration mutation pipeline. We give it a configuration file, so it fine-tune. It actually is just change the value of the configuration parameter. Then it configure the base station, collect the log. After that, something wrong, they will be handled by the LLM. So LLM will try to analyze the log and try to recommend a new parameter, new configuration file. So the red part actually is should be closed loop. But the red part here, we focus on the training data generation. So the data we generate, the configuration and the log, we will give it to NVIDIA. So NVIDIA, as I know, maybe they use H200 to do the supervised training by themselves. So they fine-tune the model in C. So they provide us the fine-tune model. Then actually now I think Christian, his work is we try to use the fine-tune LLM to to monitor, to collect the data. Actually, you need to collect the data directly from OAI. OAI, they have email reflector. So email mailing list, you can get all the user, they will raise their question, give the configuration for those, they have configuration and the log. We can use LLM, try to analyze, try to make sure whether the fine-tune LLM are able to solve the problem. So finally, ideally, we want to contribute the fine-tune LLM to OAI open source community to select some of the FAQ from the user to relieve some of their loading. The same procedure actually we also want to apply to different open source. So we can use the same framework, for example, to work with Akudu to help them to generate a log, the payload configuration and log to analyze it automatically. So that's what we are trying to do. So Johnson is responsible for the red flag. Then he tightly co-work with NVIDIA to see how to, for example, in configuration patient prompt, they just use LLM to try to adjust parameter, automatic adjust the parameter, such as they are able to generate configuration file That's what
I
we
see.
are doing.
So the documentation of the real life or AI, where are you going to put it? Later put them in their GitHub or
Yeah,
for the
actually,
real life?
we upload it to Hugging Face. So all the fine-tune model, our training data are already on top of the Hugging Face.
Okay. What
So
is?
we want to open source everything.
I see. What is test SFT? What do you mean by test SFT with real life configuration problem? Yeah.
The secondary variables, that's what I previously mentioned. We want to use the fine-tune model to actually help open air interface to fix some of the real misconfigurations issue or some of the issues related to misconfigurations.
You should mention SFT LLM.
SFT,
yeah, SFT means supervised fine-tuning.
Yeah.
So means the fine-tune LLM model. We use the open source model. So in NVIDIA, they use our data to train the model. The train model is they use super fine-tuning to train the model. So we call it SFT LLM. So this is on
That's
the left,
interesting. Yeah,
right-hand side. Yeah.
So if you go to the website of OAI or Open Run now, the contribution of this edition of LLM and plus pertaining
Not
to
yet,
NVIDIA?
not yet. We
Not
want to,
yet.
we want to try it first.
Oh,
We
I
want to
see.
make sure how many questions raised by the user are able to select by this one.
I see.
Because not even all of the issues are related to software or misconfiguration. Some of them are most likely the hardware issue or the network issue. That's why we need to filter out all of the issues from the email or the GitLab. That's why we're trying to work it.
Okay, good. If you go to the website of Oran now, what is the location and how far people are already implementing? This is an AI to Oran, right? Already.
Yeah, this is to be AI for RAN. Yeah. We designed some module to support the RAN operation. I think this module somehow can be used for intent-based networking as well. Yeah, because the purpose is the operator now is a human. We want to use the LLM to replace the human. So hopefully the SFT LLM should be knowledgeable for the configuration. It could be an agent, AI agent for configuration.
So any of them doing agent for this?
No, not yet. But we have another student. As you know, we have another student who is just graduate. He tried to use AI agent for intent-based networking. For this part, they just for example, they want to increase the network slicing, the slice by 10%. So human just give the human language. So we use AI to translate the human language to the configuration parameter. So then they can use the configuration parameter to control the IF to adjust. So IF understand the configuration translate by the AI agent. So it can create a new policy. So I will create a new policy to enforce near-time read to adjust the throughput or the bandwidth for each slice. So this is what this student is doing now. Yeah, but we try to put everything piece by piece together.
Yes, yeah. Interesting. Is there any paper or any publication?
We just yes, we for the intent-based network, we just have a paper published in global Infocom in
Portugal.
In May. No, this time is in Tokyo.
Milan. Oh, okay.
Infocom this year is in Tokyo. So this is a paper by BMO. By BMO, they have a 6G AI RIM workshop under Infocom. So BMO already published this one, and we also have another new student, master student. Now he is working in Eurocom. In Eurocom, his topic is also
Intent-based networking,
but it's run on top of this Bubble Run platform. So
Bubble Run.
So he will come back and do everything on top of OSC. Yeah, all Run software community OSC platform. Then we try to combine new IFSF everything together. Yeah.
Interesting. Yeah, I hope that you can go more and do things, because AI implementation in RAN is very important, and we need to write it soon, otherwise everybody talk about it, but we didn't have time to publish. Yeah.
Yeah, that's what I will focus on the rest of the 2 months.
Because the deliverable number 3 is something that newer models, what kind of newer models that you foresee at the moment?
Well, of course, newer models
like
Gemma 4, that's what I, because this alone, Gemma 4 alone already bypassed the Heinzel model. It got like 100% accuracy. Meanwhile, the Heinzel model only get maximum 90%. That's what I'm looking for. And I
interesting
bigger data sets.
And you choose this modified cell search parameters that you would like to check.
Yeah.
How did you decide?
Yeah, this is all the parameters that will affect the cell search flow, because we want to separate it into 4 different flow, like this one. This is the entire, it's too big. If we only benchmark the entire call flow, it's too much, and we cannot see each model, where does it lacks in which specific communication flow. So I chose that specific parameters that will affect only cell search. I will find other parameters that only affect random access, other parameters that only affect, etc.
Okay, very good.
Thank
Yeah,
you very
this
much.
good work on it.
For the next student will be Deva.
Quickly dwelling into the. This is new Nemotron and things. I don't even know how
Yeah, sorry.
to share. Yeah.
Okay, good afternoon, everyone. So, I will be going to report at least just a short introduction of what I'm doing, then my last progress. What I've been doing right now in BMW lab is basically evaluation of AI implementation in low Earth orbit, or as we call it, LEO, in satellite routing, or in scientific term is called ISL, or in satellite link. So basically, in short, unlike the LEO satellites move very fast, but it causes frequent topology change and overseen also unstable routing conditions. Since LEO satellites move at 7.8 kilometers per second, it makes the network highly dynamic. So, and most existing routing approaches are extension of graph algorithms where satellites equals nodes, ISLs equals edges, and then the routing is basically just the path selection problem. And as you may have already known, the routing part, most of them is just basically find the nearest neighbor. That's just the metric that most people use, as you may have known from like OSPF or from internet routing. Basically, the metric is how much is the next hop, and then they will try to choose the fewest next hop route. So across the 8 papers I listed here, all from IEEE, as you can see here, is from the last 3 years, both from journals and also conference. There is a recurring pattern emerge whenever you try to search or look up Leo regarding the topics or titles discussed. Most of them use reinforcement learning because Leo satellite routing is naturally a sequential decision-making problem. So the routing is not just like find one shortest path once, as I have mentioned before, maybe using Dijkstra. It actually becomes when in each time step, we must observe the network state and then choose the routing action and then receive feedback on the delay or loss or the throughput. After that, the model must improve the next decision. That structure matches reinforcement learning very well. As you may have seen this diagram here, this is the most basic diagram of reinforcement learning. It's the basic concept of reinforcement learning, where you can see here what kind of things that each state, action, reward, and environment, and agent relates to into satellite networks. So the thing is that for future researchers, we need a repeatable workflow and module. So this is what I'm trying to focus on in this BMW lab. Is so that they can use publicly available standard simulation tools such as Hypatia or SNS3 that's built on top of NS3 to compare classical and AI-based routing under the same time varying topology. So because using this such tool is useful for future implementation and research when trying to consider everything for research or optimizing satellite and so I think I'm not going to take a look into my plan of progress. I'm just going to skip into my latest progress here. So
Go back first.
Oh,
Okay.
this is just the plan on progress here. So right now, I think I have already gone past the week 3 progress in my week 1 and 2, since I consider myself to already familiar with Hypatia and their data structures. So for this week, we want to progress. We have a positive result proof of concept. So for you who might not know what Hypatia is, Hypatia is a low Earth orbit satellite network simulation framework. It calculates network state over time and then enables a packet level simulations using NS3. So basically, there's like 2 layers inside one program. The top is the Python program. That's what Hypatia framework is. And underneath that, the first layer is the NS3 to enable packet level simulation. So we have an experiment here. It's a basic scenario from Hypatia paper. So I may have mentioned this to Prof. before. Hypatia is actually proposed through a paper, even if it's just a software. And this experiment here, we have basically 2 flows of satellite connection. One of them is from Brazil to Russia, and then another one is from Brazil to Iran. And what is the problem in this satellite scenario? The problem with this is it's called a 2-compete scenario. The original experiment here is trying to basically present a contention between flows on shared inter-satellite links. So this is the visualization of the simulation using Hypatia. This is the 10 megabit per second satellite, where this is the flow, the first flow, where it's from Brazil. This is the connection from Brazil to Russia. And then after that, we see the second flow of connection. This is the connection from Brazil to Iran. And if we take a look at the metric here produced by NS3, it's the throughput here is 3 to 6 megabit per second, even if the satellite actually supports 10 megabit per second. Why is that? Because it has a congestion. Since if we take a look here, both TCP flows travel in the same direction over those 10 megabit per second links. The shared segment caps aggregate useful rate around 1 link's capacity. That's the problem. So even if maybe this route might be the shortest path for both satellite connection flows, it's not actually a good route or link for those connections. So what I'm experimenting on right now for the last week is that I'm training one of the most basic reinforcement learning model. It's a Q learning, if you might have never heard of it, where we set the reward. The 100, the plus 100 is when the action reach the satellite 345. Satellite 345 is our destination. And then -1 and -25 is basically the penalty, where for every other forwarding step and also additional penalty when the directed edge is already used by the first connection flow. So basically the reward expresses a clear objective where we have to reach the destination with few hops, while avoiding expected saturated capacity. So it's just the training parameter that I'm using. And then we see here that the Q learning flow actually learns a different route that's much better compared to the original paper. This is the, if you're confused by what is the comparison between all, here I enable all the flows. So you can see that in the first one here, we have a shared bottleneck on the purple line, and the new path comes from the blue lines there. So here we have a much higher throughput. It's a 98.5% difference, but we are not trying to basically try to prove that, oh, this is a concrete proof that AI implementation is much better. No, see, so basically this is just a proof of concept that AI or Q learning can actually adapt to a dynamic scenario where many kind of metrics can be imputed other than the fuse distance or routing. Also, other than that, the round trip time for the TCP connection gets reduced. It improves because removal of the shared bottleneck reduce queuing. So I think for now, that's just my progress. Thank you. As for my plan, I'm trying to implement this into another simulation program called SEO to see if the Q learning model can actually be run in any kind of simulation program. That's all from me. If there is any question.
So Java, how do you, what was your experience with Hypatia? The key learning itself, where did you put the key learning method? The algorithm itself is in, Hypatia is for the Leo.
Yeah.
Yeah. And do you have any picture that connects them?
Oh, the picture is I think I can try to use this diagram. So basically in this this one here, so in Hypatia there is a program or maybe basically a core module called SatGenPy. SatGenPy basically means satellite generation Python program. And the point of SatGenPy is to basically build a graph that connects each satellites. And what the AI model tries to do is basically generate a text file called fstate0.txt. fstate0 is basically like the routing table for the satellites, and we can actually try to choose the original fstate0.txt, the routing table file from output from the SatGenPy itself. But the proof of what this proof of concept trying to do is basically the AI can actually try to use what SatGenPy output and then make it so that the TXT file or the routing table file generated by the SatGenPy program can be better compared to what SatGenPy output. But keep in mind, Professor Lily, right now this is still an offline reinforcement learning training. So it doesn't actually interact with NS3 as of now. If we try to interact with NS3 for online RL training, then the reward, there must be a feedback loop from the NS3. So basically the throughput, like the throughput here, this measurement must be input to the model again for the training. Right now, our definition for the reward is basically we already define it so that there will be a penalty when the directed age is already used by the previous connection flow.
Are you going to connect them later?
Yeah.
During the yeah, and what is there anybody already put together the reward thing with other method or anything in paper?
In paper,
Yes.
there is one of them. There is this deep graph. Wait a minute, Professor. Deep graph. This one. This last paper here, deep graph, dynamic Leo-centered routing approach based on deep graph attention and incremental evolutionary reinforcement learning. They are using an online training for using a raw NS3 program. So basically, they are not using Hypatia or SNS3. They built their own simulation using NS3, and then they use. Have you ever heard of Gymnasium program or OpenAI Gym? This is basically a framework to train and validate many different reinforcement learning approach. So basically, they create interface from the OpenAI Gym to NS3. This one is the closest one that I will get to my thesis or my research because we use NS. Also, OpenAI Gym is actually deprecated. So the latest progress or the latest news is that they make it fully open source with no trademarks from OpenAI. So the license open source license has become much better compared to before. It's called Gymnasium rather than compared to OpenAI.
So is there anything from this last paper that you think we can overcome the problem with the approach using Hypatia rather than their own?
Okay, so I think the closest one that we can try to do in Hypatia is this one, the deep graph attention and incremental evolution reinforcement learning, and also the Markov decision policies, the MDP, because Markov decision policies in time the routing is basically like is actually very basic. They are trying to make a similar approach to key learning, since MDP is like a very baseline of the reinforcement. And then the other one is this one, GNN and DRL integrated approach. The reason why I choose those, I mentioned those papers as my answer. The other papers like the dividing topology model and the multipath, the quantum reinforcement learning, and the mega so also this one. This one can be used. This is actually one of my baselines here, the enhanced key learning study, dynamic topology. Just the other papers that I mentioned here will be complex, and even if I try to understand it, I don't think it can truly be implemented in HiVision in a short time windows is I only have 2 months left here.
Very good. Yeah. If you can read the last one, it's already very good. And then try to change it with iPad. Yeah.
Yeah.
Okay, yeah.
Yes.
That's good. Please give Eva a big applause for reading a lot. Yeah.
Maybe continue to my next one.
Anybody use Garmin watch? Garmin watch. Garmin. It's for sport.
Yeah, I know.
And the cable.
Yeah.
Do you have anybody have the cable? No. Because I left mine at home. I cannot wear mine.
Okay.
It's 1 week.
Ada yang pakai Garmin watch nggak di sini? Kabelnya nggak ada ya?
Okay.
Samuel. Good afternoon, everyone. So my topic is auto lab, and it is powered by IRA.
How does it
So some brief introduction from me. So me 30 years as a 10 student from Indonesia. My major is information system. Currently active at BMW at SN intern putting a meeting and assistant research. So first one is research. Assistant research is an app that will assist the user when they are writing a paper, like ranking the best paper with the result. So the diagram like this. So the user or the researcher provide the research content or the research they currently researching, and we either fetch from either EEE or we using the OpenLX API, and we ranking the best paper based on the abstract.
Yes.
Yeah.
You
want to buy
and we use for ranking it.
Cable.
For the next one is AI inventory agent. So AI assistant that lets you manage hardware, software, or any inventory by using Snapchat and connect it via MCP. So this is my
You can show me.
when trying to list the available inventory in Snapchat via Open Cloud. And the next one is AI meeting agent. So AI meeting agent is time trap and summarization system that I will develop during these 2 months. And I combined 3 LM for the job to work. The model I use is PLS, Gamma for B, and Whisper for the speech to text. And the diagram is like this. Like we can use interface like Open Cloud or MCP to connect it via the AI agent. So this is the my attempt to try use the transcript model I developed, the agent I developed. So this is I using open code via MCP. So what is MCP-R? So MCP is like the open standard by Anthropic, but and now is hosted by Linux Foundation. So it is universal adapters standardize how AI agents securely connect to external data source, tools, and system. So thinking it as a USB-C for AI, just like the USB-C port standardized how physical device, and instead of hopping
the model understand the API, we just develop the MCP to AI understand the tools. Maybe that's all from me. Thank you.
So Samuel, how far are you with the integration now? This is the model, right?
The agent.
Yes.
Okay. So I currently doing the AI agent meeting. It is working for the transcribe and summarize the transcript in the meeting. For the next thing I will do to connect OpenCloud or Canvas agent via MCP.
So the real problem itself is about operation of company. Yeah? The problem, the problem itself.
From a meeting.
Transcription of the talk and then the. So OpenCloud itself you use for
the interface. So like we upload the recording of the meeting on the OpenCloud, and we like can you please transcribe this meeting, and the LM will working to transcribe the meeting and summarize it all.
Okay. Yeah, good luck.
Okay. Maybe for the next one is
ITB. He's from ITB. And Alvin is not here. Andy Alvin is in the company. And Edward.
We feel
Sorry?
we feel.
Two people, yeah, it's not here.
You?
Yeah, I'm asking about another student, Andy Alvin. Andy Alvin itu di Artilat. Different, not from you.
Yeah.
Oh,
we have lab intern in the industrial intern.
I see.
So they go to the company.
No, nothing for one from Artilat here. Oh, hello, Nigeria. Oh, I see. Okay, now from ITB.
Hello everyone.
Okay.
And now is we started with a system nobody is already there, but it's not working and all this. And the first big connection has passed. Today I'll cover what's done, and also architecture. Okay, so as I have explained it now, why this project has existed. Actually, the previous student left a fixed system that was properly tested, so nobody could trust it or turn it on automatically. So that's a problem because the lab's real goal is having AI automatically deploy this kind of system that is provisioned by Mr. And AI could not safely control something vulnerable and also unreliable. So that's we have three goals here. The first one is to make it easy for everyone to set up from scratch to prove it work, and also to later connect it on AI as a bonus tool. Okay, So here is the 8-week plan. So the week 1 is fixing the basics, it's done. The week 2 is getting the 2 main systems talking, also done. The week 3, now currently doing is full deployment end to end. So now we're facing the NFO and deploy. And the week 4 is checking the network connections. Week 5 is later adding the metrics, adding the monitoring diagram. The week 6 builds the AI connection. The week 7 is later on the demo and also paper. And week 8 we wrap up. So for today we are on track, and the hardest part is already behind in week 1. Okay. So for the system architecture, we could see here that the system from top to bottom. At the top is the future AI control layer that we are visioning for. This is not built yet, by the way. And below it is the management layer, the SFO. And it handles login, it handles deployment requests, and also connects securely on a open source platform link. So this all runs on Kubernetes across a few machines. One already runs on a working test app, but another is reserved for the radio hardware with one physical slot is available. From there, it connects to the 5G radio network. The radio software is now deployed, but 2 of its links is to the real-time connector and also the physical radio. Physical radio unit are not fully working. So a monitoring spec we see on the side is for them to collect data from both layers and also for the and shortly, this big system architecture is for management, and also the platforms are really proven. So the radio network is deployed but not fully wired up for the AI. That are we currently focusing for the next milestone. Okay, we move to slide 5. Where are we now? So actually, the biggest blocker is now solved. The 2 main systems has connected successfully, and we can deploy something real to the connection. The test app is up and also reachable. Security was done properly, not as a shortcut, and the 2 suspected bugs turn out to be nothing. So one real gap remains is one network component has a. Okay, so now for the target architecture. Here we have 5 clear layers. This is the direction I'm doing first. From the physical server, from L1 to the L5. So in the L5 is the plain language command. So each one connecting to the next to a stable and well-defined link through instead of everything tangled all together. This lets the AI layer be added later without breaking what's underneath it. That is why there are 5 layers. Complicated, but this is what needs to be done. To make this richer, 7 things need to happen. The first is to lock down how layers talk to one another, fix a few fragile shortcuts in the code, make logins recover automatically, make deployments more reliable, add real monitoring, keep secrets out of the code because there are several secret keystrokes in the documentation, and finish one accurate diagram. So in short, we need to discover reliable self-recovery, well-structured, and also secure and staying in scope. That's the plan. That's the plan going forward. Maybe that's from me. Thank you.
So, Bogi, who are you collaborating with, and what did you get before to start your work?
Okay, so actually, I'm collaborating for the final project. I'm collaborating with Radit for the AI intent. But before student he's called Nino, and he's the graduate from NUST. He's from Telkom University, if I'm not mistaken, and he has a very good thesis. There's my job to be done to make that thesis to be really reliable and also reproducible.
Okay, so what is the new thing that you would like to introduce here? Any tools, any new things that you pick up after him?
Actually, there are not very much things new, but I'm very related to this project. So what makes me here is how can I contribute so that his work is really reproducible and also can be collaborated later on as the hands also relax for Radit. Radit. After me later.
Oh, okay. Right. So what I don't understand what is healthy here. What do you what is
It is it is very technical for the blocker. So the first there are three blockers for the
what
bottom
blockers?
register. Yeah, this is the bottom registers. This is the output project, and also this is the NFO. So this is all clear, very already finished. As I configured, this the output object is already received as the cubic config filing X. Also for the HTTP, firstly it is error 404, but later on it is finished with the bottom register starting go to IMS. And here, this is what I have finished just now for the NFO today, very much today. The NFO is already working from yesterday and also today, and also has already continued live on worker. So before we have Joy. Joy is actually another student in QSD. I collaborated with also to really focus how that platform that we have can also be connected with the NFO so that it can reproduce the NFO. So at Qualcomm and also NFO is actually also the part of SMO for the OPA. Demos like the brain.
That's great.
So what he's doing is so proud. He just hand over a job from Nino. If you remember, Nino. Nino's from Telecom University.
Oh yes.
Another
I remember Joy. I
Nino.
Nino.
Nino, yeah. Just very general.
I see.
But actually, he has been working in Telecom University for more than 2 years.
On this.
So he come here, he want to
my name is and now I'm going to present about my career progress in this internship. So for introduction, RAN is evolving toward the Open RAN now. So where the near RT or non-RT RIC, it enables an AI-driven control. But it grows a network complexity and makes a traditional optimization methods insufficient. So the LLMs here offer a reasoning, generalization, and agentic capabilities beyond conventional machine learning, making them promising for tasks like intent-based conflict, fault diagnosis, and resource allocation. So for my topic research here is LLM for AI RAN, where this AI will integrate AI models operate as a central brain to a network and lab automation. So the AI brain map also maps directly to the service management or an orchestration or CMO component in the ORM architecture layer, collaborate with the cloud infrastructure and team to execute an intent-based network scenarios, and the platform automates the network operation and manages daily life productivity. So this is my system architecture for my research, where we as a user will give like a prompt or comment to a server later. Currently, we have two server DES Spark, and the first one is a 126 server, where this server has Game4 and Whisper model. And right now, currently, it also has the open cloud that has been running for this past week. And these two, the JS Spark server have a shared memory pool. So the data, each data in this server has it's really connected. So in the other DGS part or on the 122 server, it has the model Nematron model. And right now, for today, I have deployed the GPT OSS model in the 122 server. So in this particular server on a 122 server, it will act as an intent parser, policy generator, and a JSON coder. So this will connect to the LTM server for the log and history via RRA query, cloud infrastructure, and a near RT RIC for the traffic as apps and the energy as apps. So in the server, I have deployed several models. I have deployed Nematron 3 Super 120 billion models, a Whisper model, Gamma 4, and GPT OSS. So the Nematron has been used by Nelson for his training model. Whisper has been used by Samuel for his transcribe. Gamma 4 has been used for the OpenClaw, and GPT OSS will be used for the file code for the coding, and especially on the RAM that I will test later. So for my goal in this internship is to build an agentic LM to operate as a control plane with an SMO layer for the oral automation, create an autonomous lab assistant platform to manage files, summarize document, and handle daily administrative tasks. And last is to integrate the AI brain with the cloud infrastructure to execute an IBM or intent-based networking command seamlessly. So for my current progress, this is the current screen server that has been running. For the on the top, it already has 3 screens that has been running for the GPT OSS Copilot that I believe it being used by TNs and Amazon 120. For the 126, it has Demo 4, OpenClaw, Amazon 30B that I will later deploy for to help Rafi for his config for the genome and Whisper model. That I also test the model and it runs completely fine. So I also use the Nematron through file code in the VS Code. So the VS Code, I am not using Copilot anymore. I have connected to the one of the extension. It's called Continue, and on Continue I connected to my local LLM, and I use the Nematron model to file code. I want to make a Python code to the recursive problem, and the Nematron works well, and it works completely fine with the code. But later I need to connect into the MCP. Later I will connect the MCP to the in BMW Lab we have an SOP for how to write like daily log, daily plan, and other else. And I will connect to the MCP and connect into the continue, so the module will read from the MCP to learn how the SOP in the BMW. So in the on the OpenClaw that I have deployed, yeah, I tested, and I also made the MCP to the snippet that somewhere requests to inventory management. So OpenClaw, as I said, OpenClaw is running on the 126 server, and I have tested and connecting to the snippet to the inventory management, it completely it runs well. So it detects the snippet model MCP, or later Samuel will make. And that's all from me. Thank you.
Can you show us the architecture again, the one that you already tackled? So before you in Indonesia, before you left, which part did you do?
For the probation, I also I only deploy on this date where I deploy the Nemaza model and test it.
I was asking Prof. Cheng, how did you have access to the of NVIDIA?
The DGS part or the NVIDIA model?
The model.
On the model. There's a website called Hugging Face.
Oh, put it in Hugging Face.
Huh?
Yeah, you use Hugging Face for that.
I use Hugging Face, and in the Hugging Face, it
Already
much all the model that I need to deploy, and I can deploy it. So this Nematron model is from Hugging Face, and I use this for the deployment.
I see. How far are you going to effect the ORAN, the last part after physical execution and parameter execution that you have? What is your intended product later impact to the whole?
Okay, so for the impact, or I will make the right now I've been developing the Rust agent. So this agent will act as an intent-based network. So whenever I want to I want to save more energy on this tower, or maybe I want to test this config. So I just type the prompt, and this Rust agent will receive my prompt and will connect to the Nemotron as a LLM level, and it's not just give me the feedback, but also do as an AI agent that to the maybe the tower or maybe a cloud infrastructure. Yeah.
Tangan dulu, Bro. Radit, tadi tangan. And Nelson is the last one. Which one?
Hey, good evening, everyone.
Oh.
My name is Nelson Laurentius, also called. Today I wanted to present my topic in BMW lab. The topic is zero touch ORAN configuration via AI ML lifecycle automation. This is the outline of my presentation today. And first, what is the goal? My goal in this project is to building a zero touch automated AI ML lifecycle for 5G networks within the ORAN architecture. And currently, deploying and managing AI models in telecommunication is a manual process. The left vision is to have an agentic AI in management layer or SMO that can autonomously instruct the network to train, deploy, and manage the machine learning models to optimize the network performance without human intervention. And this is for my overall system workflow. Before diving into my specific task, here's the high-level architecture of the entire ORAN intent-based network project. And you can see this is the official. Wait, we cannot zoom it. Yeah, this is the official from the OSC. The first, the non-RT RIC or NF, to user put his or intents, and example, this is a training request. They will go to the training manager, and the data will fetch by the DME from the InfluxDB or the data lake, and after that, it will trigger the training on the kubeflow environment and execute the pipeline, QoE pipeline in the kubeflow. And after that, we can store the model And if we want to deploy it, we just make an indent again in the archive to the agent. Example, deploy the deployment request, and it will deploy the model to the case of environment. Caser is the container to put the trained model, and it will make an inference service that the inference service will call by XF or near RIC. Next, what is my role in this project? My specific responsibility is building the execution bridge and orchestration layer. And I'm responsible to taking the high-level command or intents that I said before from the AI brain and executing them on the cloud AI/ML framework infrastructure. And I am implementing the standard ORAN interface using the Apache Kafka and building the automation engine that control the machine learning training pipelines and the module service point. Next, the PRD, what is the objective? The objective of this project is to enable the seamless intent-based communication between SMO agentic AI and a cloud AI/ML framework to achieve the zero-touch module cycle. And this is the key feature and requirement for this project. There's the standards communication using the R1 interface. There's the train, retrain, and deploy. And the second is the automation execution engine that build a consumer that listens to the intents and automatically triggers the workflow. The third is zero-touch model serving, and once trained, the model must be automatically deployed as active endpoint via Kserve, so that the XApps can consume for the near real time prediction. And the last is the must be robust against the network timeouts, and if there's any implementing that ladder queues and exponential backoff, it will handle itself. And this is for the specific system architecture what I do. You can see first, this is the SMO or service management orchestration. There have the agentic AI and LLM brain. I use the DSPY from the ORAN official GitHub, and the Nemotron that it said before I use for the LLM brain, and it will publicly intent to the topic. There's three topic. I create the SMO intent, SMO status, and SMO that letter. After published to the intent, it will next to the intent customer or my automation engine that will automatic receive the intent from the agentic AI, and it will trigger the training or deploy. And when it trigger the training, it will go to the training manager and running the QI pipeline for the training. QI pipeline is the AI model using the TensorFlow to train it. And when it finishes the training, it can deploy the model to the Kserve test the inference service. After that, it will give the status callback to the SMO status and give back to the agentic AI on the SMO. And if there's invalid intent, it will go to the topic SMO that letter and will give the status to the SMO. Okay. Next, this is the three-phase zero-touch lifecycle that I said that I have successfully validated the train, deploy, and inference. The inference will make the model becomes the active HTTP endpoint and ready to serve to the prediction to the network. And what is my current progress? This is my current progress complete for 3 weeks. I have successfully deployed the core infrastructure and established the communication bridge there. I have deployed the AI/ML framework and Kafka production from the official ORAN AI/ML framework. on the lab's Kubernetes cluster and migrate from the local testing to the prediction grants in the Zcash cluster and running natively on the Kubernetes with the external node port access. The second is zero touch lifecycle that I say. It can automatically, if the model is already trained, and we say to the agentic AI to train again, it will automatically be retrained. And the third is the prediction and hardening the science that I say. I implement the early stopping in the machine learning pipeline to optimize the training time when it prevent the timeout and the model get no efficient again. And I also build the DLQ with the RFC schema validation. This is to reject the malformance payload with crashing the system consumer. And I've add the explanation backoff to retry logic when the server is or network is failure between the components. And this is my current focus and the next step. For the immediate action item is that's the bicycle RTX 4080 machine from BMW lab to our Kubernetes cluster, and I will batch the Kubeflow training pipelines using the node selector that will constrain to force all AI training jobs to exclusively using the GPU, because for now the training is using CPU there very slowly. And the status is I'm waiting the RTX 4080 machine because it's currently being used by another lab members. So I'm waiting for it become available to use. And the final for the long-term goal is I want to intend the big gather my testing trip that the final phase of my project will be replacing my test trip and connecting my Kafka or consumer system directly to the LLM and being developed by the SMO. I think that's all from me. Thank you.
Very nice. What's your name? Nelson, yeah. Nelson, when I was asking about the machine that you're using, what is other student doing for the RTX 40? Why do you have to wait?
I think
For doing what?
sorry.
You're waiting what for doing which part?
The RTX 4080 is being used, so I must waiting for. I want to run.
Who is using it? Professor Riri.
Yeah.
I don't know who is using by my mentor Joseph said. There's
who? Can he still use?
I think he did.
Oh, now? Yeah, you can check with him. I guess it should not be used all the time.
So what is your plan to do that? Can we go then again? Nelson, Monday or Friday kuliahnya?
I'm Friday.
Okay. All right. So what you are going to do is for the purpose of this.
I want to switch the AI training from now is using CPU. I want to using the GPU. Yeah. And then I want to join the node. For now is using the worker node. I want to joining it.
The intended products later on is documentation of the result of the test.
Yeah.
Of making sure that can we go again to the first? Yeah. Will integration, yeah, SMO agentic AI. And you already have some LLM works.
Yeah, I successfully make the training LLM. And it can deploy it on the K-serve.
On?
K-serve. K-serve is some container that used to deploy the model trainer, and it will give you URL that can use the different service.
I see. In simple words, the agentic AI in this case is what are the agents? Can you mention
Oh,
few
there's
agents?
there's the two I use.
Uh-huh.
There's the AI manager. AI manager is the I use the DSPY. DSPY is the agentic AI for the intent. Intent is the from the network auto from the network engineer that use the LLM from Reddit Nemotron. And for the worker AI is the QoE pipelines that used to train the model.
Okay. So two.
Yeah.
And you use OpenClaw in the beginning to get the pipeline itself.
The pipeline is from the AI model QoE pipeline. I use the model for the worker to train the model.
Nice. Tangan dulu buat Nelson. How far are we going to finish this implementation of agentic AI for just two purposes?
I think it will finish. For the LLM
Yeah.
AI is finished yesterday, but but the SMO is I make the intent is for now is used from the Python script I make. So I want to make it more realistic and use the SMO. So I must for the final I must make the SMO can work automatically like I said in the first presentation.
Okay, very nice. I think everyone is already presenting here. Congratulations, everyone. I'm very happy. You are from, yeah. Are you from Thailand? You're not going to present? Yeah, I'm very happy to hear all of you are doing very well. And this is amazing. I mean, you are, I think one day you should to put together and put the word in a simple explanation so that we can see that, okay, when they run internet rakyat, they are buying this box of which box that you think that you are in. That I would like to know all of you to tell in a simple words what is your contribution. Yeah, and during the history also of the team, you know, because normally our work is to do the testing, yeah, and also to do the documentation of the results, and then people can go for it. But if you eventually have something, is there any GitHub or any contribution like that you can share, like data or anything with the product? Repository. Okay, because now you can also write apa sih namanya istilahnya sekarang data apa ya? But there is something that is only data in brief, method in brief. If anybody produced this before, this is something new because check data in brief of no, it's Scopus. Scopus also. The data itself. Yes, yes. Yes, yes. Yes, but the writing or the publication of the data itself is called data in brief and methods in brief.
Yeah, maybe you can check if there is anything in the past. Yeah, and anybody can tell about the result of the previous, because we are starting from 2016. Is there any repository of all the things that they do, and is it still here?
Oh, yes. We have specifically now we have to sorry, and we collect everything.
So if you